And so it is, in which we will discover the uses and applications of fetch. We're going to start trying to make fetch a thing. All right, let's talk about what it is. So you tell me, what's fetch do?
Makes a GET request.
Mm-hmm. That is one of the things that it can do. Any guesses what else it can do? And make a get. It can also make
Post request?
It can make any kind of request, really. All we're doing in mod 2 is get requests, but worthwhile knowing, it can make any HTTP request. Really, that's really what fetch is about. It makes HTTP requests. Now, the thing that gets confused is two things that are not maybe as straightforward as like REST client was for Ruby. First thing is promises. We'll talk about that in a sec. Second thing is we have to parse the response. Where's that word again? So the fetch request that you're going to make in mod 2 almost all have the same shape. And they look like this. Fetch URL, then parse the response, then let's say handle response, and then if anything goes wrong, we want to catch it and handle an error. There's lots of other things we can do with fetch, but if at the end of mod 2, this is all you know how to do with it, that'll work for right now. So let's talk about parsing the response. That's this part right here. The most common confusion about parsing responses with fetch is that somehow you're turning the response into JSON. No! JSON is the response. JSON's a string. Or kind of like HTML was, it's not even that, it's just some characters. JSON is not an object. It's object notation. It looks like an object, but ultimately, just some characters. It's up to your language to turn that JSON into a JavaScript object, to turn it into a Ruby hash, to turn it into a Python dictionary. Every language has some kind of structure that works like that. JSON gets used with all of them. JSON is just a way to pass data over a network. But we can't do anything with it. We can't iterate through the arrays. We can't go through the keys of it or anything like that because it's just some characters. So we parse the response and turn those characters into, in this case, a JavaScript object. And we got a built-in way to do that.
Can I ask a question about JSON?
Please.
So, can you use JSON format in any language, or does it have to have some sort of object orientation?
Any language. It is the current lingua franca of of moving data over networks. Used to be XML once upon a time. Now it's JSON. If you're moving data over a network, there's a like 99% chance it's formatted as JSON. Good question. Parsing a response works like that. What's up with that little fucking fat arrow? That's kind of new. What's that?
That is an anonymous JavaScript function, if I recall correctly.
Yeah, that's an anonymous JavaScript function. So that means that that's the exact same thing. I can either write this or I can write that. They both work. These two things are identical. More and more, you're going to see fat arrows, especially like by the time we get to mod 4. You'll probably see a lot more fat arrows than you will these, which are called function declarations. But they're doing the same thing.
Kyle, sometimes after the fat arrow, there's a block of curly braces.
Yeah. So
why? What's the difference? Yeah.
So let's write this out a third way. That's the same as these other two. If we do it all on one line, we don't have to do the curly braces or the return keyword. That's the one case in JavaScript where we have implicit returns. Has to fit on one line though. If we need to use multiple lines, wrap it in curly braces, and then after that, it's exactly like it was when we were using the function keyword.
So is the fat arrow essentially just saying like pass this variable into the function that happens later?
Yep. We also can have, there are a few different ways we can notate that. If you only have one argument, or what, sorry, one parameter, then you can do it like that. You could also write that in parentheses. If you have no parameters, but it's still a function, you have to use parentheses. You also have to use parentheses if we're doing more than one thing. But if there's only one thing, which is the case most of the time, in our 80-20, that's the 80. You can actually leave the parentheses off. and that's pretty common. If we've got nothing, we need parentheses. If we have more than one thing, we need parentheses. If we have one thing, we have the option of leaving the parentheses off. So yeah, you can just think of those parentheses as exactly like what they are here. Works the same way. But instead of using the function keyword, we can put a fat arrow after it. Works the same way. What else do you want to know about fat arrows? So let's talk about promises for a sec. Promises are one of the, like, I'd say academically most complicated things we do in the program. So if they don't make sense right away, don't lose too much sleep about it. It's going to take a sec. A promise represents an eventual value. A promise represents an eventual value. A promise represents an eventual value. We might not have the value yet, but we might have it in the future. And so a promise represents that future value. For example, when we make a fetch request, we don't want the program to stop while that happens. You've seen this before, and it's made you mad. If you've ever done a site where you click a button and it like freezes your browser, you can't scroll anymore, you can't click on anything, you can't do shit, and then it sort of like jerks back to life. That's called a blocking request. It probably did something like make a fetch request, and JavaScript can only do one thing at a time. And if that thing is wait for the fetch request to come back, it can't also handle your clicks and scrolls and all that shit. It's busy waiting for the response. So the way that we get around that is promises. We say, hey, I want to fetch this, make an HTTP request to this URL, and then go on, do the other stuff that you need to do. Whenever it comes back, then parse the response. Believe it or not, parsing that response also happens in time. So we go, by the way, whenever you're finished parsing that response, then I would like you to handle the response. But you're letting JavaScript, that JavaScript engine that we were talking about this morning, you're letting it keep going. Another example. So right after this, I write console log hi. The way this works, we trigger this fetch request, this HTTP request in this first line here. That makes the network request, starts waiting for it. The console log is the very next thing that happens. These thens mean, hey, we're just waiting. JavaScript, do what you need to do. As soon as something comes back, we'll do what we need to do, but you can keep working. So that happens, then that happens, then this happens, then this happens, and hopefully this never happens. ask me some questions about that.
So do we only use promises with like fetch requests, or do we use it with all sorts of things?
We use it with all sorts of things, but the thing that they have in common is that they're asynchronous, meaning that like they take some amount of time and we don't want to block the computer while it's doing it. So common things that we would do asynchronously are HTTP requests. Also on the back end, any kind of file access. Like sometimes it takes a while to read a file or write a file or something like that. So we want to block the program while it's doing that. So we handle those in promises. Database requests also on the back end. Any kind of database request, that takes time. And those technically happen over networks. They're kind of like HTTP requests. So we don't want to block everything, but we can use .thens to still control the order that things are happening in. I don't want to parse the response before it comes back. I certainly can't handle the response until I've parsed it. So if I need to control order with things that are asynchronous, that's what promises are for.
If you're working with multiple APIs, can you have multiple fetches? And how does the order work for that?
Sure. So that's a great question. You can do this a couple ways. You can do them as different promise chains. So I fetch first URL and .then and .then and .then. Oops. And then I could say fetch the second URL So if we did something like this, I want you to think about what order each of those lines is going to happen in. Think to yourself for a sec. What order are these lines going to go in? Carlos, what do you think?
I think it's going to read the first fetch and then jump over all the thens, read the second fetch, and then it's going to probably jump up to the first, see if any of the thens have been met, and then go through that line if that's the case. If not, jump back down to the second fetch and see if any of those have been met.
Bravissimo, very nice. So if this fetch finishes first, then that's probably the one that's going to go. But maybe it's here, and maybe this next one happens before anything else over here. So then we just go right to that. And hell, maybe we do the entire chain before we jump up here. The important thing is, it doesn't fucking matter. This still happened after this, and it still happened after this. That's the part that counts. And we let the JavaScript engine worry about like which ones actually go in which order. We know that that's going to go, and then that's going to go, and after that, just depends on what happens next.
So it can jump back and forth between the thens. So it can do the first then, and the bottom then, and it doesn't matter as long as it's sequential beneath the fetch.
Correct. Any one promise chain has to execute in order, but it doesn't necessarily execute in that order with nothing in between.
Do fetches generally occur faster if it's just like a smaller API?
Yeah. Or if it's on localhost or something, it doesn't even need to actually go over the network. It's just talking to your computer. Those are pretty fast. But when we're writing asynchronous code, you can't count on something usually resolving first. Because whatever, it might be a super zippy API, but I don't know, even good APIs have bad days. So if something depends on something else happening first, it has to be in a promise chain.
Could you put a second fetch inside of that promise chain?
Yes, you could. If like your second fetch depends on something that comes back from the first one, then yeah, you can absolutely put a fetch inside of another fetch or somewhere in its promise chain. Totally allowed. One thing you'll not do as often, but is also allowed, is we can say, I'd like to do these two fetches, and then when both of them have finished, I'd like to do something with both of their responses. So that looks like, uses a utility called promise.all. That's a capital P. Promise.all is a method, and it takes in an array of promises. So that could be like fetch first one, fetch second one. So we have an array of promises. Promise.all will wait for both of them to resolve. It'll fire off both of them, and when they're both done, you can dot then off of it, and you have access to both of their responses in an array. Pretty cool.
So then your response would be like response array 0 and then response
Exactly.
array 1 or whatever.
Correct. Like responses. You won't do that one as much, especially not in mod 2, but it's a good one to have tucked away to know that you can do 2 or more. You can do 50 fetches at the same time, and then wait until all of their responses are back before you move on. Promise represents an eventual value. If you need to get that value, that's what .then does. If it fucked up at any point, like your network goes down, the server's down, the internet's down, something unpredictable happens, then it goes to the .catch. Give me a question. I love questions.
What are the other promises besides .then and .catch?
So the promise, so like calling fetch, you fetch and then the parentheses, it's a function. The return value of that function is a promise. And with any promise, you can .then, which is a method on every promise, and you can .catch, which is also a method that exists on every promise. But the result of a fetch call, that's the promise. It's an object. The result of this response.json method call here, that's a promise. It will eventually be whatever the parsed response is, but it takes a sec. So the promise represents this kind of wrapper around the thing before it exists. We can still pass it around, but we need to wait for the result of it if we want to actually use it. And we do that with .then. It's a tricky one. Ask me more questions about promises. Cool. So let's talk about the exercise from this morning. I wanted you to fetch something from an API and make it show up on a page. That's kind of like the core competency of Mod 2. Fetch something from an API, build an API, fetch something from it, make it show up on a page. And then the other way, fill out something on a form and then add it to an API. You can do those two things, you're a successful Mod 2 grad. All right, so we're in this fetch practice thing, none of this, you get how it works. So make an index HTML. I'm going to make an app.js. We get the drill at this point. Doc type HTML. Come on, man. There we go. Needs title. Everything needs a title. Needs a character set. Everything needs a character set. All right, so I have this HTML page. I want to fetch from the Poke API, make a list of Pokemon show up. So I throw that app.js file in here. And I fetch from pokeapi.co/api/v2/Pokemon. It's almost like I've used this API once or twice. And whenever that comes back, I want to do something with the response. Let's take a look at what the response is first. So just that right there, that's what let me take a peek at my response. Let's make sure I'm serving this up. Fuck you, Chrome. All right, so there's the Pokemon thing. Let's take a look at the console. Hey! So this is what I got back. It's an HTTP response. It's got a status code. It's got the status text. It has the URL that I asked for. Has whether or not it was a good kind of response, like a 200 or a 300 series, or a bad kind of response, like a 400 or a 500 series. It has any headers that came back. And it has this body. Now the body, it's not the JSON text yet. It's complicated reasons why that's the case, but that's a good thing. The bad part is that we have to parse it. Okay. If I return that as JSON, all right, whenever you finish parsing that response, so we can call this, if we wanted to write this out as long as possible, that's the HTTP response. This is the parsed object. So I could take a look at what the parsed object is. All right. And this thing right here, that's what's coming back from the Poke API. It says I've got 964 Pokemon. It actually gave me a URL that will tell me what the next 20 are. This only gives me 20 back to start with. But if I want the next 20, I can follow that one. I can make a fetch request to it if I want. And if I take a look at the results, hey, that looks like Pokemon. So parsed object dot results is this array of Pokemon. It's got a URL that I could follow to get more information about that Pokemon. Otherwise, it just gives me the name. But if I wanted to follow that one, come on back, Bulbasaur. Even without fetch, if I just go to that in my browser, hey, it gives me everything I need to know about Bulbasaur, including its pictures. Yay, it's Bulbasaur. All right. Well, hey, if I just have an array of these things, I know how to do stuff with arrays. We talked about this in the last lesson. I could do, well, shoot, let's just take one for right now. Parsed object results 0. All right, so that's Bulbasaur. I get the DOM element out of the tree, make a new element, add the new element I made to the tree. Okay. So Pokemon rn document.querySelector.Pokemon. My Bulbasaur element is going to be document.createElement li. My Bulbasaur's text content is going to be Pokemon.name. And then I'm going to take, I'll take that Pokemon container that I had and append Bulbasaur to it. If Pokemon's not defined, you're not defined. Let's see, that was Bulbasaur.name. Hey, look! I looked something up from an API and made it show up on a page. Badass! The power! The power! What if I want to make all of them show up on a page? Why, that sounds like that same thing, but with like a map and a for each. So I can take these results and then I can put all this kind of stuff in the map. Move that out of there, actually. We'll call that just an li. And this is Pokemon.name. And this one is li.textContent. And we're going to return the li. And then we're going to for each all those LIs that we made. And append them to the page. And if we do all of that, they all show up on the page. Sick.
So you wrote all that inside of the second then function.
Correct.
Is that a common, or is it general to place it outside and then place whatever function you're looking for inside the then?
So let's take a look at what I can and can't put inside of that function or out of it. Looking up this little Pokemon container, I don't have to wait for the fetch request to come back. I can do that whenever. Because that exists when the page loads. There's nothing special about that. Might even make more sense to leave it out. All right, cool. Parsed object dot results. All right. Well, I need to have a parsed object to do that. So that has to exist in here at least. Now, the stuff inside of this, if I want to do it in line with this fat arrow, that's got to be there because I'm working with that. If you want to see the advanced way to do it, we could make a separate function called like create Pokemon li that takes in a Pokemon and does all of these things. But what we're doing is saying create Pokemon li and passing in Pokemon and returning it. We could do that.
Which is more standard practice?
The pro way to do it is what I just did, but even tighter than that. So what map takes is a function definition. Coincidentally, that's the same thing that .then takes. It takes a function definition. Create Pokemon li is a function definition. Okay? So if this function definition I'm using here is this fat arrow, okay. But if all I'm doing is calling another function with the same argument, fuck that. Just do that. .map takes a function definition. Create Pokemon li is a function definition. That's the pro way to do it. If you can't wrap your head around that in mod 2, I would not lose any sleep over that. That's a mod 3 as hell topic. We couldn't do that in Ruby for what it's worth. We didn't have a way to like store a block from Ruby in a variable and then like pass that into map. There's no idea like that in Ruby. Well, it kind of is, but it's less common. So instead, this is a perfectly fine place to start, just doing the function inline. But if you want to know the fancy way to do it, that's what it is.
Can you talk about the response type being cores and what the cores gem is?
Oh yeah, very nice. So cores is really, really simple. People make it way more complicated in their head. We go over to the network tab in DevTools. We'll look at this request I made over to the Pokemon API. This access control allow origin header, that's cores. The end. If that header exists on your response, your browser will let it happen. If that header does not exist on your response, your browser will not accept the response from the fetch request. It's a security thing. It's not a security thing for the API, it's a security thing for your browser. Don't worry too much about why right now, but good. There's a very good reason for that. Which is why, if you look around on All About Code in the Flatiron Slack enough, inevitably there's going to be somebody going like, I have this funny CORS error coming back from my API, and some dumbass will tell them to like install some browser plugin that disables CORS protections in your browser. Don't do that. That's a terrible idea. All CORS is the presence of that header on the response. And whatever, that can be a star, it can be the name of your domain, it can be lots of different things. It just has to be something that kind of matches what you're asking for.
For some reason, I thought that Coors was the banquet beer.
Very nice. That's CORS, just the existence of that header. Rails has a gem called CORS. Any guesses what it does?
Puts those headers in for you?
Puts those headers in for you. It's all it does. Magic.
So is that like how people control access to who can change the API, or is that completely different?
That's completely different. This is purely remember, it's not keeping the server safe, not keeping the data safe, it's not keeping any of that shit safe. It's keeping you safe. Your browser is trying to protect you by only accepting things that have that header. The reasons for that, again, complicated. Don't worry about it. But it is a very legit security thing your browser is doing to protect you. More questions?
Okay, I have one.
Yeah.
So if you are getting back like a bunch, so you're getting back a bunch of data with your fetch request, and you want to do like several different things with that data, like would you do it all in one fetch request, or would you do like multiple fetch requests to the same API and pull different parts out of it, or like what would you do?
It's a good question. In general, a network request is the slowest thing you can do in an app. So you want to make as few of them as possible. If you get some data back once, save it, reuse it, like do anything you can to avoid making more network requests because they're super slow. Like the stuff you do in JavaScript is measured in microseconds. Stuff you do over a network is measured in seconds. So, all right, I get this list of Pokemon back. I want to add some properties like favorites. I want to make sure I've got all of Elise's favorites in there. And I want to display them. And I want to add any ones they don't have to a database. Whatever, you have all these different things you want to do. Only make that fetch request once. And then like this, these can be function calls or whatever, however you want to organize it.
But you would never just want to like save what that parsed object is to be able to then like go back and re-reference over and over again.
You could, but here's the tricky part about that. All right, let's say I want to So I've got that variable out there, and I go, all right, I got my Pokemon back. Okay, cool. So now all Pokemon is set to whatever I got back from this response. Wait for it. As long as I'm in here. Think about this diagram that we did. Where is it? Here. 1, 2, 3, 4. So this is an empty array. I make the fetch request, and then I do some other things. Okay, but it's still an empty array here. It doesn't have all those Pokemon in it until after this. Now, if like do thing 1, is defined out here, I can do thing 1 and it can refer to all Pokemon dot map and do whatever else with it. That's fine. But I need to make damn sure that that doesn't get called before that's populated. And at that point, why not just pass it into the function like that? Students always want to like keep the result of a response in a variable outside of the fetch like this. There's ways you can make that work, but it's usually not worth it. So remember, if we need the result of the HTTP response, it needs to exist somewhere inside of this .then. Now, these things that we have in there, that could be millions of lines of code. Could represent these functions that control like our entire app. Still needs to be after the response comes back. What else? Okay, one more thing since you brought it up. Let's say I've got a backend, a Rails new API, and the -- API is extra important for the thing I'm about to show you. Make a new API, and it's my horsey API. Cool. So now I've got that horsey API in this folder. So if I want to add that CORS header, here are the steps. Step 1, go into the gem file and look for rack CORS. It's on line 26. Yeah, line 26, and uncomment it out. That's step 1. Step 2, bundle install. Step 3, there's a file called config/initializers/cors.rb. You open that up, and comment out this part and change example.com to star. Done. Now,
What does that star do?
So you'll see this throughout programming. It means any.
Okay.
The technical term for it is wildcard. That's cores. Now, anything that comes back from your API is going to have that header. There's more to cores than that, but if that's what you leave the program knowing how to do, that'll work.
So like if you just wanted to have the cores look at just the Pokemon API instead of star, would you put pokeapi.co?
No, it's the client. So what you do is say, I only want my app, which is running on localhost 3000. That's the only allowed domain. But that's the thing it's looking for. Now in production, that might be KyleCoberly.com is the only, actually I think I need the entire protocol in there also. KyleCoberly.com is the only website that's allowed to use my Horsey API. Remember, this doesn't protect the server, it protects any user who happens to be on KyleCoberly.com. It's for their protection, not mine.
How do you do multiple but not all?
Comma separated. What else? Uncomment it out in the gem file, bundle install it, uncomment this thing out in the course file. Put your origins in.
Why do you do a bundle install instead of just a gem install for the cores gem?
Oh, great question. Because I want to, when I bundle install, I'm saying I want all of the things in that gem file to be installed. When I do gem install cores, it's on my computer. Cool. But here's the dangerous thing. Let's say I just leave this commented out and I gem install cores. Neat. This will work for me. I run my app, it's gonna have that header on it. Cool. Now when you fork and clone my app and you try to run it and you don't have cores installed on yours, it's not gonna work. Because it's just expecting that it's somewhere on your computer. And this is why I think Gem is the shittiest package manager I've ever used. This is just a bundle of bad ideas. It was very influential, and it was like one of the first really widely used package managers. But God, that is a design flaw if I've ever seen one. That doesn't happen with NPM, which is like the node version of Gem, because all of the dependencies are installed per project. Gem just throws it all over your computer. So that's why I do it that way. Other questions about fetch or cores or promises? So we use it to make HTTP requests. If we want to do something with the body of the request, we have to parse it. We don't just get it for free. We use promises to control the order of things where they might take an arbitrary amount of time. Promise is an eventual value. We can dot then and we can dot catch promises. The order that things happen whenever we're dealing with asynchronous code, we don't have a whole lot of control over it. It's not always intuitive. But we use dot thens to make sure that things have finished happening before we do things that depend on them. Cool. Check chat real quick. Bundle install bad ideas. File already exists. God, I love this cohort. Cool. Have fun with Jesse. Bye.
Thanks, Kyle.
Yep, yep.